We're going to find the limit of tangent squared of x divided by x as x approaches 0. This is a graph of the function, and from the graph we can tell that the function appears to approach 0 as x approaches 0. I'll leave a link in the description to a lesson where we go over the limit of tangent x, so not squared, just tangent x over x as x approaches 0, which has some similarities to this problem. If we try just substituting 0 into this function, we get 0 over 0, which is an indeterminate form. So if you know L'Hopital's rule, you could use that, but we're just going to use algebra and our limit laws to evaluate this limit. You'll also need to know the classic limit sin x over x as x approaches 0. This is equal to 1 and will be useful in evaluating this limit. All right, let's get into it. First, we can rewrite tangent squared as sine squared over cosine squared, since tangent is sine over cosine. Then we can just move this cosine squared into the denominator, just to simplify the fraction a little bit. And so we now have the limit as x approaches 0 of sine squared x over x times cosine squared x. Now, we could just plug 0 into cosine in the denominator, since cosine of 0 is 1. So let's just take this cosine squared out and see what that leaves us and what we can do with that. That gets us here, sine squared x over x, and then we just brought the cosine squared out into its own fraction. So this is multiplied by 1 over cosine squared x. Now, here on the left, we have sine squared x over x. We would like these two things to match, so sine squared x over x squared. Then we could use a limit law and this known limit that sine x over x is equal to 1 when x approaches 0. So to get the x in the denominator to be x squared, we'll just multiply by x over x. Then in the denominator, we'll have two factors of x, and of course we now have this additional factor of x on the left. So again, all we did was multiply this by x over x, so there's that extra factor of x in the numerator, and then the x in the denominator is now x squared. Now we can split this up into a product of three limits. We have the limit of x multiplied by the limit of sine squared x over x squared, multiplied by the limit of 1 over cosine squared x. And we can rewrite this limit of a product as a product of limits because all of these three limits exist. The limit of x as x approaches 0 is obviously just 0. The limit of 1 over cosine squared of x as x approaches 0 we can find by just plugging 0 into cosine. Cosine of 0 is 1, you square it, it's 1, and so this is just 1, which we see here. Now, as for sine squared x over x squared, this is a composite function that we have going on. We've got sine x over x, but the whole thing is being squared. And so the limit of this is going to be the same as the limit of sine x over x, but just square that limit. The limit of sine x over x as x approaches 0 is well known. We know that to be 1. Link in the description to my lesson going over that limit if you're not familiar with it. And so this just becomes 1 squared, which is 1. And so finally, the limit is equal to 0 times 1 times 1, and that is just 0, which agrees with our graph that we looked at before. So the limit of tangent squared of x over x as x approaches 0 is 0. I hope that was helpful. Let me know in the comments if you have any questions, and I'll leave a link in the description to my Calculus 1 and Calculus 1 exercises playlists if you're looking for more.